Hello students, I hope you're all fine, and also I hope that you would have written the physics test nicely and you would have known all the theory questions and theory part of it. So it's very important that you understand the theory very well so that the numericals can be solved nicely. So today we're going to start with some of the numericals in the example questions. So turn with me to page number 435. So in page number 435, we will do question number 3. It's a very interesting question which has quite a lot of components in that one. It's a bit lengthy also. Try to understand clearly. I'll just read the question for you. A cord is wound around the circumference of a wheel. There is a cord is wound along the circumference of the wheel. You know about the wheel. So it is something like this. So this cord is wound on the circumference of the wheel, right? And this is the axis of this one. Now it also says the wheel is 0.5 meters and a mass 2 kg is tied to the free end of the cord. So a mass 2 kg is tied to the free end of the cord. This is what it is. The next one is, and the mass is allowed to fall from rest. So it is just falling from here and it's just going down. That means when it is going down, what happens to this one? This will rotate fast. Okay. The wheel also rotates very much quickly because it's just coming down. The axle of the wheel is horizontal. The axle is horizontal. That means this axle is horizontal like this. And the wheel rotates in the vertical plane. The wheel rotates in this way. Okay, that's what the wheel, it is vertical plane, it is so said. The mass falls 4 meters in 10 seconds. That means this mass drops down for 4 meters in a time span of 10 seconds. Within 10 seconds it just drops down, right? Find the angular acceleration produced and moment of inertia of the wheel. So you're supposed to find out alpha, angular acceleration, and moment of inertia I. So there are two things it is asked. One is called, so I've written radius of the wheel and mass. So alpha is equal to question mark, moment of inertia is equal to question mark. So these are the two things it has been asked here. It's a pretty interesting question. We need to see very carefully how it goes. Okay. In other side, if you see in the top perspective, okay, in this from this side, if you take a look on it, this is a radius. And much of this one is wound like this, so this one will be dropping straight like this, and the mass straight away drops down. So when the mass is dropping down, you will find the tension is acting downwards, and this will be acting downwards with the weight of G, and it is going down with the acceleration A. So you find here, when it is coming down like this, there is a torque which acts here. What is the torque? Tension, which is acting downwards into the perpendicular distance's radius. So you will find torque, it is going to be there. Torque is responsible for rotating the whole thing. So that is one important value of torque, which is tension and radius. Okay. And the next line is, also we already know the formula of torque is called I alpha. So we can also see what is that. Okay. So let us try to write down the very first thing. When the mass drops down, the wheel rotates with torque. Torque is going to be equal to tension into radius. What is this one called as? Tension. Please write down. Into radius. We already know torque is going to be equal to I alpha. Alright. Equate both this one. So it is going to be equal to tension into radius is going to be equal to I into alpha. Right. Now we need to find out all of them. so that finally we can get into the final things. You need to find out what is tension, question mark. Radius already we know, it is already given here as radius is 0.5, right? Radius we know, and moment of inertia we need to find out, alpha also we can to find out. So we need to find out, this is the A part, tension also you need to find out, and then this is the B part. Once A and B part you found out, then you can find out the value of this one is the main question mark. There are three things which is not known here. Tension we don't know, only radius we know, I is actually also asked, alpha is also asked. So alpha you can find out, and I also you can try to find out using this one. But this is the main equation. This is the main equation. Equating torque is the main equation. Okay. Now I will go ahead of to find tension, or to find alpha. If you want to find out alpha, what you can take it as is, it is dropping for 2 with a 2 kilogram, it is dropping for 4 meters. From here to here 4 meters it is dropping down with an acceleration A, in a time interval 10 seconds. So what you can write here is, initial velocity is 0, acceleration is equal to question mark, alright, and then time taken is equal to 10 seconds, and distance is going to be equal to 4 meters. So S equal to ut plus half a t square. 4 meters is equal to 0 plus half into a into 10 square. So what does it mean by that? It becomes 8 is equal to a into 100. So what is acceleration is going to be equal to 8 by 100. It is going to be equal to 0.08 meter per second square. That is the acceleration. This is A. What is alpha? Okay. A is equal to, acceleration is going to be equal to R into alpha. We already know linear acceleration is going to be equal to radius into angular acceleration. So you can find out alpha here, which implies alpha is going to be equal to A by R. So what is alpha is going to be equal to 0.08 upon what is radius? The radius of this one is 0.5. So it becomes 0.16 radians per second square. So that is the first part of this one. Now look at this one. In this one, alpha is known now. This is 0.16 is the answer. Right. Now we have to find out tension here. Tension also we need to find out, and then equate all of them here. Next line. To find tension on the string. So what is the equation you need to put? We have already, we know the equation. Whenever a body falls down, so for tension you need to see it as the body is coming down with the weight as m into g. So you can see this one here. So the body is coming down with the weight of m into g minus tension. So this is pulling upwards. So this pulling upward, the tension is acting upwards here. Minus tension is going to be equal to mass into acceleration. Right? So what is tension is going to be equal to mg minus ma. So tension is going to be equal to m times of g minus a. So that's what the point to find the tension is already done. Now we can put this one in the main equation. The main equation already I told you. Tension into radius is equal to I into alpha. Straight away put in all of them. Okay. So tension into radius is equal to put I into alpha. That is the equation of torque. So what is tension? M into g minus a into radius is going to be equal to I. What is alpha? Alpha it is already known here as 0.16. Right. Now you need to substitute all of them. What is mass? Mass is the mass of the body which is coming down. This mass, 2 kg, right? 2. This is 9.8 minus what is A? Acceleration, already we found out the value of A. A we have found it as 0.08. So that it is 0.08 into radius. What is the radius? It is 0.5. It's going to be I into 0.16. So substituting everything, you will get a value of I. Okay. So try to find out the value of I. You will get the answer. I am just writing it from the book itself. It is 60.75 kg meter square is the answer you will get. Okay. Pretty long question, but it is mainly revolves under this one. Torque, tension into radius. That is the torque. Force into perpendicular distance is equal to I into alpha. So that's what the thing is, and you got the answer. Let us go to the next question now. Question number 4. A light cord is wound round the rim of a flywheel. What is a flywheel? Write down flywheel. So flywheel means it is something like a same rim only, okay, where you will have maybe something like this. So these kind of things will be put here so that it will start going around. This is called a kind of a flywheel, and the rim is also already there. Okay, so sometimes it will be more, it will be thick also, and sometimes the entire thing also it will be covered. So it will be kind of a disc, you can say. Flywheel, it is nothing but disc. Please remember. Right? Now write down. A light cord is wound round the rim of a flywheel. So there is so much of cord is being wound around this rim of this flywheel. That means it can come down also. And a mass of this one flywheel has the mass. So the disc has a mass of 20 kg. Radius is 0.2 meters because 20 centimeter, 0.2 meters. Mounted on a horizontal axis. So this is in the horizontal axis with a frictionless bearing. A steady pull of 25 newtons. How much it is? A force of 25 newtons, right, is applied at the free end of the cord. Find the angular acceleration. A part, angular acceleration, alpha is going to be question mark. B part, work done by pulling. What is B part? Work done is question mark. And then C part, kinetic energy, is going to be a question mark. So these are the three things you need to find out. A, B, C. Right? And D part is also there. Compare the answer between B and C. That you can see it later. Okay. So in fact this one is a flywheel having a lot of cord which is there, and it is just coming down with a force here. Right? So first of all you need to find out the moment of inertia. Moment of inertia of disk. Moment of inertia of a disk is half mr square. Half into mass of the disk 20. Radius of the disk is 0.2 the whole square. So what happens here? It is this one 10 into 0.04. So it's going to be equal to 0.4 kg meter square. This is I, moment of inertia. The next line is alpha is to find out. Okay, now you can easily find out alpha as torque is equal to I alpha. This is the first one. Torque is going to be equal to I into alpha, right? So we need to find out alpha. I is already there. Alpha you need to find out. Torque, how to find out? This is the force. Force into perpendicular distance. Force into perpendicular distance is radius. So torque is going to be equal to force into perpendicular distance. It is 25 newtons. 25 newtons is applied force into the radius is 0.2. So that's what the torque is. Alright. So you get here as what do you get here? You get here as 5 Newton meter. So you can substitute all of them here. 5 is going to be equal to 0.4 into alpha. So what is alpha is going to be equal to 5 upon 0.4. So what's the answer here? It's going to be, it is 12.5 radians per second square. So that's what the alpha value is. So first part is over. First part is alpha value, angular acceleration is over. Now second part, work done. Work done, write down. B part is to find work done. W is going to be equal to. So what is W is going to be equal to? So it's going to be equal to tau into theta, right? So we need to find out the work done here. There are two formulas. Work done is going to be equal to tau into theta, or work done is going to be equal to force into distance. We have this also. This parameter also is there. This also it is quite possible to find out, right? We can try in both the sides. So work done is going to be equal to force is 25 newtons. So this is 25 newtons, and the distance traveled. How much the distance it travels? It travels of 2 meters. When 2 meters of card, right? So distance is going to be equal to 2 meters. So work done is going to be equal to force into 2 meters. So work done is going to be equal to 15 joules will be the answer. If we find theta, we can also try to find out what this tau theta is becomes. It becomes equal. It will become equal, right? So we'll do it a little later, and we can see the next question and then do it. Kinetic energy. You need to find out the next is kinetic energy. So C part is kinetic energy of rotation. Okay. So what is kinetic energy of rotation? K is going to be equal to half I omega square. Omega we need to find out. We need to find out omega. So if you want to find out omega, now let us try to find out the parameters here. What are the parameters which needed to find out the omega value? Right? It starts from rest. So what is omega naught is 0. What is alpha? It is 12.5 radians per second square. And what is the time taken? So the time taken is already there. Now it says, so work done in 2 meters. Okay, there's no time taken here. It's okay. When there is no time taken, you can easily find out with the theta value. Theta value you can find out. You need to find out the theta value. Then you can easily put this value as omega square minus omega naught square is equal to 2 into alpha into theta. This formula if you apply, you will get omega square. But we need to know theta value. How to find out theta value? There is one very important hint over here. The hint is the work done to pull 2 meter of cord is unwound. So 2 meter of cord is unwound. So it just rotates from here it starts means 2 meter it winds down. So what does it mean by that? The linear distance upon radius. The distance upon radius. That is the total theta value it is gone. So it is going to be equal to 2 meter upon what is the radius? The radius is here. The radius is going to be equal to 0.2. So 2 meter upon 0.2. So what is the theta value? Theta value is going to be equal to 10 radians. Now put everything here. Put everything here. Omega square minus 0 is going to be equal to, because it's at rest. Rest is there. 2 into what is alpha? 12.5 into what is theta? What is theta? It is already here as 10. So what is omega square? Omega square is going to be equal to 2 into 12.5 into 10. It's going to be equal to 250. That is omega square. So we are not going to find out omega here. Omega square itself is fine because you have to substitute in this one. Omega square is needed. So what is omega square? It is here. Now going to the next part of it, how does it go? So kinetic energy is going to be equal to half into what is the moment of inertia. Already we have found out this one. Moment of inertia already we found out in the earlier one. It is moment of inertia is going to 0.4. So it is going to be equal to 0.4 into omega square is 250. So finally, what is the kinetic energy? So kinetic energy is going to be equal to 50 joules. So kinetic energy is going to be equal to, this will get cancelled out, so it's going to be equal to 50 joules will be the answer, right? So it's quite a easy thing. Now it is asked here, compare the answer of B and C. What is B part answer? B part answer is 2 meter cord. The work done, we already saw. The B part answer was 50 joules. What is the C part answer? C part answer is also 50 joules. So compare with B and C. Why it is same? The entire of the work done is converted into kinetic energy. According to the work energy theorem, the entire work done is converted here. Alright. Two important questions, big questions. So there are 3 parts in this one. We are derived everything. Try to take a full look once again. Take a full look, pass it on, pause the video, and then go ahead of one by one how it has been solved. Okay. Let us go to the next question now. The next question is page number 437, the next page, question number 5. A body whose moment of inertia is 3 kg meter square. Moment of inertia is given here. So I think it's better to keep following up this question here. So I is going to be equal to moment of inertia, fifth question, it is going to be equal to 3 kg meter square. It's already given here. It is rotated for 20 seconds. Time is given here as 20 seconds. With the moment of force, torque is given here. Moment of force means torque is equal to 6 Newton meter. 3 important parameters is given here. Now look at this one. Torque, I. Something quite, torque is going to be equal to I into alpha. That is quite an easy thing. Find the angular displacement of the body. Angular displacement means theta is going to be equal to question mark. But here, you can easily find out the alpha value. So torque is going to be equal to I alpha. So alpha is going to be equal to torque upon I. So it's going to be equal to 6 upon 3. It's going to be equal to 2 radians per second square. That's the very first part which has already been right visibly here. Now because of alpha here and this timing here, time is given here, you can find out theta here by the equation of motion. The theta is going to be equal to S is equal to ut plus half at square. What is the formula? Omega naught into t plus half alpha t square. Do you know all of them? Yes, we know all of them. Theta is, you can easily find out, omega naught is 0 because it is starting from rest. Is it written there? Is at rest. So it is the 0 plus half into 2 into 20 square. It gets cancelled out. So theta is going to be equal to 400 radians. 400 radians is the answer. First part is over. Angular displacement is over. Also calculate the work done. The second part is to find the work done. So next line, to find the work done. So W is going to be equal to tau into theta. Torque into theta. What is torque here? It is going to be 6. Already it is given there. Into 400. So it's going to be 2400 Newton meter. Sorry, not Newton meter. It is joules. That is work done. Okay. So it's quite a simple question. Nothing much in it. It is very straight. You find out alpha, and this is the main thing. To find out theta is the main thing. Once you found theta here, work done is going to equal to tau theta, right? So The next few questions we are leaving here, 6th, 7th, 8th, you need not do it here. So we'll quickly get into the next part of the topic here, which deals with moment of inertia and angular velocity. So if you look at this one, page number 441, right? Based on moment of inertia, kinetic energy of rotation, law of conservation of angular momentum. So we'll be mainly doing with law of conservation of angular momentum. That's the main part of it. We'll be seeing it, right? 14th question is a homework for you. Please do it yourself. I'll start with question number 15. Please write down question number 15. So before going into this main thing, I'll tell you law of conservation of momentum, angular momentum. So it's going to be equal to I omega is going to be equal to constant. In other words, I1 omega 1 is going to be equal to I2 omega 2. So this will be the main thing. The angular momentum, the initial angular momentum will be equal to final angular momentum. So this is the main focus, it will be there. Rest of them will know how to calculate the moment of inertia. We can do it at that time, right? So look at question number 15. Torques of equal magnitude are applied to hollow cylinder and a solid sphere. So you have hollow cylinder and solid sphere. We need to find out the moment of inertia of both of them. So this will be I1, this will be I2. Hollow cylinder means it's going to be equal to mr square. Solid sphere, it will be 2 by 5 mr square. Alright. So hollow cylinder and the ring will be same. If you take a ring and a hollow cylinder will be same moment of inertia. Okay. Now since these two are given there, I1 and I2 is already there. Look at the next part of it. The question goes on to say, the cylinder is free to rotate about its axis symmetrical, and the sphere is also free to rotate about the axis passing through the center. Which of the two will acquire greater angular speed after given time? Which will have more speed? You are just giving a same torque. So one is a cylinder and it is rotating. Next one is a sphere. So that's also rotating. Now it is asked here, this is omega 1, this is omega 2. Which will be greater? Which will rotate with a greater angular velocity? So that's a question mark. So we need to figure out how it will be here. Now there is nothing much given here. Nothing much is given here. Okay. So the thing is, torque is equal. Torque is equal. So what is torque formula? I1 into alpha 1 is going to be equal to I2 into alpha 2, because torque is equal. So I1 upon I2 is going to be equal to alpha 2 upon alpha 1. What is I1 value? I1 value is mr square. What is I2 value? 2 by 5 mr square. It's going to be equal to alpha 2 upon alpha 1. Right? This gets cancelled out. So what is the rest of the value here? So it is going to be equal to 5 by 2 is going to be equal to alpha 2 by alpha 1. So if you take alpha 2 is going to be equal to 5 by 2 of alpha 1. So the alpha 2 rotates very fast because it is this much times of alpha 1. So alpha 1 it is less and sphere gives faster speed. Therefore the angular acceleration of sphere is greater. How much? It is 2.5 times greater than the hollow cylinder. which is 2.5 times that of cylinder. Okay, we'll go to the next question now. So the next is question number 16. Take a look on this question. A solid cylinder of mass 20 kg. Just write down solid cylinder. What is the mass? M is equal to 20 kilogram. Rotate about its axis with an angular speed of 100 second minus 1. That means omega is going to be equal to 100 second minus 1. Radians per second you can write. Omega is given, the angular speed is omega. The radius of the cylinder is 0.25 meters. R equal to 0.25 meters. Now the question is, what is the kinetic energy associated with the rotation of cylinder? Kinetic energy is going to be equal to question mark. Please write down. And what is the magnitude of angular momentum? J vector is going to be equal to question mark. These two things are given as a question mark. Right. So these are the basic parameter which is being given here. Solid cylinder with M and all things are given here. So first of all, if you want to find out the kinetic energy, so it is going to be equal to half I omega square. Omega is already given there, but I is not given there. So for solid cylinder, moment of inertia, what's the value? Moment of inertia of solid cylinder is half mr square. It will be same as that of a disc. For a disc, it will be half mr square. The disc also, it is going to be much bigger as a cylinder also, same thing, right? So half mr square, which is going to be equal to half into 20 into 0.25 the whole square. So you will get moment of inertia here. This will become 10. So it is 6.25, whatever it is, right? Moment of inertia you will get here, and then you can substitute here, you will get the kinetic energy. Please do that yourself. Next one is J vector is current I omega. What is angular momentum? This is angular momentum. What is angular momentum? J cap is going to be equal to J vector is going to be equal to I omega. So I you would have found out. Omega is already here, and please find out. Alright. So what else is there? What is the magnitude of angular momentum? That's all. Okay, fine. So you can find out these two things, right? We'll go to the next question now. The next question is, a child stands at the center of a turntable with arms stretched out. So the child is standing with arms stretched out, right? The turntable is set to rotate, rotating with an angular speed of 40 revolutions per minute. So you can write it as this is omega 1. Omega 1 is there. How much angular speed? How much is the angular speed of the child if he folds his hands back and thereby reduces the moment of inertia 2/5 times of the initial value? So this child now with the same turntable is no more going to keep the hands like this. The child has kept the hands together like this, right? Now what is going to happen is the value of omega value will increase because moment of inertia decreases. I omega is going to be equal to constant. Here moment of inertia is more because the radius is more. Now here the moment of inertia decreases. It all of a sudden decreases. When it decreases, omega value should increase. That's a simple basic logic. Now you're asked to find out what is omega 2 is going to be equal to question mark. But I1 and I2 is given here. What is the value here? 2/5 times of the initial value. So the moment of inertia I1 is going to be equal to, right? So I2 is going to be equal to 2/5 times of I1. This is given here. Okay, how the equation supplies here? According to law of conservation of angular momentum, I1 omega 1 is going to be equal to I2 omega 2. So we need to find out what is the value? Omega 1 is going to be equal to 40 revolutions per minute. It's already given there. So I1 into 40 is going to be equal to 2 by 5 of I1 into omega 2. So I1 gets cancelled out. What is omega 2? Omega 2 is going to be equal to, so it's going to be 5 into 40 upon 2. So it's going to be equal to 100 revolutions per minute. Definitely it's going to be higher end speed. Omega 2 is going to be equal to 100 value. That's what the equation says. It's a very simple question, nothing much in it. Alright, we'll go to the last question now. Question number 18. A rope is wound round a hollow cylinder of mass 3 kg, radius 40 cm. Please write down. First line, hollow cylinder, mass 3 kg, r, radius 40 cm, which is equal to 0.4 meters. What is the angular acceleration of the cylinder if the rope is pulled with a force of 30 newtons? So what is the linear acceleration of the rope? So you find a diagram like this. So this one is being pulled like this with a force of 30 newtons, and it is going to rotate, right? And this cylinder is 3 kg is mass and radius is 0.4 meters. So find out first of all the moment of inertia. I is going to be equal to hollow cylinder. It is going to be equal to mr square. So it is 3 into 0.4 the whole square. So you get here I is going to be equal to 3 into 0.16, okay, 0.4 the whole square, and what's the answer you will get? 0.48 kg meter square. That is the moment of inertia. Now what it is asked here? What is the angular acceleration? Alpha is going to be equal to question mark. I already we found out. So torque is going to be equal to I alpha. You already know this formula. There is 30 newtons is applied here. 30 newtons is applied here. It is going to be equal to force into the radius is going to be equal to I alpha. What is force? 30 newtons. What is the radius? Radius is 0.4. 0.4 is going to be equal to, what is the I value? 0.48 and alpha. So find out the value here. That's all. So it's going to be equal to 25 radians per second square. That's what the answer is. Anything else is asked? What is the linear acceleration? What is the linear acceleration? So you know acceleration is R alpha. So A is going to be equal to, what is the R value? 0.4 into 25. So 0.4 into 25 is 10 meter per second square. So that is linear acceleration. Looks to be a big question, but there is nothing much. I you need to find out. Alpha you find out because you have this equation here. Torque you try to equate it and then you get this answer. Alright children, with this I close. You are given a homework. Please do the most simplest questions here. It is from page number 463, the last part, 8th and 9th question, and then start from the next page, 10th question, from 10th question and go on till 17th question. Okay, so try to finish this many questions. So 10 to 17 you can finish. Alright, okay students, thank you.